Welcome to Ceramic Expo. I'm Mike Alexander. I am your current president of the American Ceramic Society. And I also, as my full-time job, I work with Allied Minerals out of Columbus, Ohio, and I am the tap hole clay manager of technology, I guess, and that's for blast furnace tap hole clays. So anyway, we have a couple of panelists with me today as we take your questions, and we'll go over the whole Slido thing one more time. But with me today is, on my far left, is Kamal Soni. Kamal currently leads the ceramics research at Corning. They're focusing on environmental and energy applications. His team supports Corning's environmental technologies business and develops novel ceramic materials and processes for a variety of high-tech applications. He obtained a PhD in materials science and engineering from Lehigh University. And right here to my immediate left, Patrick Wilson is a senior material scientist, ceramics and metals laboratory for GE Global Research. Patrick graduated from Alfred University, so we like that. And his BS is in material science and completed his MS degree at Rensselaer Polytech, also in material science and engineering. Over the past 12 years, Patrick has had roles in research development, operations, and reliability functions. Beginning in 2008, he spent 6 years working in part as the GE Energy Storage startup team. And as part of the startup, he spent extended periods of time in Burton-on-Trent in the UK, learning to process ceramic assemblies at the Beta Research and Development Test Facility. His roles at GE Energy Storage included design, process, cost, and reliability. Now, in his design role, Pat focused on the understanding of beta alumina, solid electrolyte performance, and fabrication. So, let's see. 2 years ago, Pat rejoined the GE Global Research as a senior materials scientist in metals and ceramics laboratory, leading investment castings research team. His current work is focused on leveraging his process expertise to develop ceramic additive manufacturing process and materials. So with that, Emma talked a little bit about Slido, so hopefully y'all are getting to Slido. You're going to get an opportunity to interact with us through some polling, which will have some questions posted. We also will have a little bit of discussion about the results of the poll, and we'll move forward with that. So if you'll help me out this morning, though, I've already told the staff here I'll probably be their worst moderator that they've ever had, and I'm hoping with your help that maybe I can at least get the second worst, and that might be all right. So with that, I think we'll start. We got a couple of training questions for you first. So Siri wants to talk to me, and I'll be using my phone really as a timer. So we're going to do that. We're going to get 20 seconds to respond. So this will be a couple of exercise questions. One is, how did you get to Ceramics Expo today? And your answers, please.
You got to pull out your phones here, guys. We're at 8 people, 9 people. Keep on counting. Let's try to get 20 on this first one.
And we got about 6 seconds left. And we'll stop the polling at this time.
Maybe we should give an extra 10 seconds on this one.
I don't know. Some forgot how to get here. And so the next question would be...
I think he's going to run the results, isn't he?
Oh, is he going to run results? Yeah. There we go. Okay. Some came by car. All right. So our next question for practice.
Somebody came by a blimp, too. That's great.
We should have had somebody drop in with a parachute. What did you have for breakfast today? And go. Everybody getting a hang of this? It's really not that difficult. And I think I know when we had questions in other sessions, you could put your name if you wanted to, but we'll hold off on that as well. And that would end our polling right about now. So, one more question. Well, let's get the results. See, I need to practice too.
We need to get warmed up too, so I grabbed a coffee this morning. What about you, Kamal?
And our third question, this might be a little more important. Where would you like to see the American Ceramic Society focus their efforts? And answer. And that's all the time we have to answer our practice round. Content focusing on new process methods.
Well, that'll be a good one because I think later on we go through what new process methods all the individuals here are interested in.
Yep, hopefully so. So I guess here we go. Our first live question. What are the most important innovations and technological developments in advanced ceramics manufacturing and processing? All right, thanks for the responses. Ooh. Additive manufacturing, ceramic matrix composites, computational modeling took a 12, cold sintering took a 6, but I guess that's fairly new technology, and flexible ceramics. Very good. So, with that, we got some ceramic matrix composites. Kamal, you have any comments on those?
Well, this is not a very active area of manufacturing for Corning, but certainly this has been a very active area in research. I'm sure GE is more active in the composite space than Corning is. We are quite happy with the monolithic ceramics as it is, but certainly ceramic matrix composites are very, very interesting and offer new property combinations.
Yeah, GE is very interested, and I actually agreed with this on the ceramic matrix composites as being one of the most important technological developments, especially for the aerospace industry. I think it's been around for 30 plus years. Krishan Luthra at the GE Global Research Center is one of the main founders and has been working on it. And it's taken a long time to come to fruition. I think we're going to see something similar in additive manufacturing. I spent the last 2.5 years just really diving in and trying to understand the additive manufacturing landscape. And it's difficult. You've got to find killer applications where it's actually it's valuable for the company to put in the money to bring it to fruition. I think it has a lot to offer. We're trying to get our designers thinking about it, and I think that'll be a short, an upcoming second to ceramic matrix composites for things that GE is interested in for innovations in technology.
Very good. What we'll be doing, we'll go through most of all our questions here, and then at the end we might open up the floor for additional questions on any of the topics. So we'll do that. So could we have our next question, please? What sustainability consideration is most important to you? If you'll take some time and vote. Slido.com. And with that, we'll close the voting. So we've got energy cost of processing out in front of most of the other answers. I know, Kamel, that's probably in your wheelhouse. So.
Yes, indeed. As a company that has this environmental technologies division, over $1 billion in revenue annually, this is indeed the highest cost of manufacturing for us. And Corning spends a lot of time in my R&D group, for example, trying to bring down the temperature or the duration of the heat treatments, trying to find more efficient ways of heat treating. So I agree with the audience here that this indeed is a biggest challenge in terms of sustainability. The others are too. For example, recycling. We do a lot of work trying to reduce waste or improve material utilization, so we don't have to do that. But in many cases, if you do have waste, we try to find other applications. We try to use it within processes elsewhere in the corporation. So yeah, sustainability is very, very important to Corning, and I'm sure we touch upon all of these. Greenhouse gas release is also very important, but of course there are no regulations, so nobody is doing anything. But certainly in future we might see when greenhouse, if it's legislated, there are many technologies today that can enable us to reduce greenhouse gases or capture them and recycle them in some profitable way. But yeah, energy cost.
Yeah, I definitely would agree. In particular, we're in the refractories industry at Allied, and one of our biggest concerns, and I'm sure with many else, is the raw material costs that we see. And we're getting a lot of feedback out of China on the availability of raw materials, and and the cost of generating some of the fused products as well, and processing of some of the other raw materials that we consume. This might be something good to circle back to if the rest of y'all in the audience have some questions later about any costs of raw materials or energy cost processing, because I'd even be interested in if there's alternative materials work being done for, and what the energy costs might be associated with that.
Yeah, I think there, from an energy cost of processing, a lot of the stuff that we're looking at is on all of the new equipment, being sure to reclaim as much heat, and in the designs, think about this in advance before going out and purchasing equipment. The recycling one is of interest to me. In our beta double prime alumina plant where we were making batteries, oftentimes we were always interested in recycling, but it kind of falls to the wayside as we focus on yield. And number one, I think we should be focusing on yield, so we're not making bad product to begin with. But I think there's a lot of opportunity in recycling those materials and finding opportunities for them. So I don't know how it is in other industries, but I think that's something that's a good opportunity.
Yeah, on the refractory side, recycling often means to us repurposing. So it's not so much of what happens with our rejects and that type of waste, but it's even like how it can use recycled materials to be competitive with the virgin minerals that we typically buy. So that's sort of the thing about sustainability. Sometimes you have to think of it as recycling on our side of the business ends up tending to be if it's cost effective or not. And then that, of course, goes in line with if the availability of the virgin materials are more cost effective than recycling. So sometimes it's a double-edged sword. You'd like to recycle, but then it's not cost effective. Let's take a look for the next question, please. What is the ceramic industry's biggest challenge right now? Please cast your votes. I don't know, maybe so. And that would be all the time we have for voting. Ooh. 19 votes. Raw materials didn't get much activity. Apparently, y'all don't care what it costs. Looks like everything's about an even tie there with sourcing of new talent, and loss of expertise in retirement, funding versus metals research. Is it just metals, or would it be materials? Processing and energy costs, we kind of touched on that. I'll just go with the top one there on the new talent and loss of expertise in retirement, because we at the American Ceramic Society, we funded a new foundation, the Ceramic and Glass Industry Foundation, about 3-4 years ago. That's one of our main focuses, is extending an outreach to not only the student side, but how do we promote the industry, the ceramics industry, to our community and to students, so that we can attract the talent for the industry and keep that energized, as it will. So we have some thoughts about that, and hopefully we'll get into some new efforts by the society. But if any people have any thoughts about how they'd like to approach it, we certainly would like to entertain those ideas as well.
I'll talk to that one too. Sourcing new talent, we've got to get out there. We've got to get into high schools. We've got to get into places. I mean, I talk about how I got into ceramics, and Alfred came over to Wellsville, New York, to our high school, and went up 20 feet and dropped a glass bottle, and it bounced and it didn't break. And we talked all about ion exchange, and I thought that was really interesting. So then I pursued a career in ceramics and material science. So I think we've just got to get out there and get the exposure. We're doing some really amazing things on the material side. I mean, the periodic table is that's our playground, that's our sandbox. So there's lots of opportunities there, and we've got to make sure that it's known that those opportunities are there. Loss of expertise in retirement, I think we've got to be doing a lot of things about this. We talk about it a lot. I think there's opportunities with the cloud storage to get files out there. A lot of times we're moving so fast that we can't document everything that we're working on. But with things like artificial intelligence, you can go out there and you can find those things and you can index those files so that they're searchable when somebody's gone. You've got to do a much better thing. I mean, one thing I try to do best practice when somebody's retiring is what are those 5 top things that you did? What are those 5 top processes that you developed that you don't want to be lost when you move on? What's your legacy that you're leaving behind and what you've developed for the company? And I've seen way too many times where retirement comes and goes, someone who knew how to do something, that be it glass ceiling, diffusion bonding, all those different processes that they may have understood, we lose that. And then we've got to try to gain it back again, and we end up reinventing the wheel.
I totally agree with my colleagues here that the ceramics community needs new talent, and this event is actually a great one to acquire such new talent. We posted many open positions on the jobs board here. In fact, we brought an HR manager here to the Expo so that she could answer many of the questions that candidates ask us at the booth. So that's great. What I'm also excited about, so as challenging as it is, the new talent that's coming out of the universities today, they're very, very well versed in new skills such as data informatics, computer modeling, new characterization techniques. So the talent that we're getting, it's hard to get, but certainly it's top-notch talent. So again, this event is a great opportunity to find talent.
Well, and I'll just go along too. We also launched at the start of Expo, which would be 3 years ago. I lose track. But we started our manufacturing division, trying to get that re-energized. So I would like to ask, we have great corporate partners such as Corning and GE, many others. We have different levels of participation for the corporations within the society, but we need that corporate sponsorship. We need manufacturing division to have participation. Right now, I think we're over 400 members in the manufacturing division. We'd like to see that grow. We'd like to use the manufacturing division to help kind of focus in regions to where we can help promote the material science and ceramics in particular. I don't know, we want to touch a little bit on funding at all versus research. I don't know exactly.
Yeah, so funding versus metals research. So what I'm finding in a lot of things that we do is finding those killer applications at GE. Everybody's interested in metals versus ceramic, especially in the ceramic on the additive side. So the funding always tends to go towards the metals research. There's bigger markets. I mean, I'm interested in talking to anybody about the different markets that you're interested in and what different applications are out there. We want to be working on those. We want to be partnering on those. We want to really know what does the market need, and how do we get funding focused in those areas to bring some of these technologies to fruition.
Funding?
Well, if you're talking about internally at GE funding competition between metals and ceramics, we are a glass and ceramics company, so they are sort of very similar categories for us. And what we find is that for us, the talent is quite transferable between glass and ceramics. Many of the process capabilities we have in ceramics is actually really applicable to glass and vice versa. So we take full advantage of being a highly diversified materials company.
I guess one thing I could refer to on funding, it's a little bit different for me now since the company I now work for employs about 850 people. But I was part of a small manufacturing corporation when I was working with Riverside Refractories. We employed less than probably 80 people at the time. So funding for the medium to small size companies is probably difficult to spend on some research activities. And I think that makes it really more important that there be a participation amongst some of the smaller companies and maybe pool talents and efforts. I tell students often that they're probably going to get a job with a small to medium-sized company because 75% of the jobs are within those corporate structures and not really the big companies. So they're kind of amazed when you start talking to them about, well, you don't have all these XRF equipment to do. You're going to have to do particle size distribution with screens. And they kind of think that's archaic. But for the small to medium companies, that's about it because they typically lack resources. So some of that is going to be, there needs to be some consideration given, probably do some either shared funding or shared resources to create some research maybe for those small ventures as such as that.
I still use screens at a big companies.
They still use screens there too. That's great. But they probably buy new ones to replace them rather than calibrate them.
Yeah.
Anyway, I don't know if we need to touch on processing and energy
I
costs.
think we touched on that.
Touched
On the last one.
So if we could have our next question, please. What skill sets could your team benefit from to help drive innovation in your industry? And respond.
We definitely love to hear from you. So if you can stop into slido.com and respond to this one. I mean, it's really important for us to find out where do we really need to develop skill sets working with the different universities. We had a discussion about this with Alfred yesterday, and trying to pull together what training sessions, what really needs to be done to move the industry forward.
I guess that's time.
We got above 20 that time. We're good.
Okay, and our responses are data analytics is a big one. I know that with the data analytics, I think we probably could look at that also as even just having the people available to work with equipment and then also analyze the data. So we had modeling. Modeling was second. Traditional processing and testing were tied. I don't know. I always sometimes feel testing's almost like data analytics, but maybe there's some separation of that.
Yeah.
So I agree. Data analytics is a critical need facing Corning, and I'm sure many of your industries and even beyond the ceramics community. This is a very new trend. Many of the people, like myself, who've been active for many years, are not well versed in this aspect of technology. And this is why I think getting new talent or retraining, old-timers like myself is very, very important. But as my colleagues also alluded, we have a lot of data already that exists in various forms. Somebody's hard drive, somebody's publications, and it's just a big Herculean task to get all the data together in a way that we can meaningfully learn from it and search from it. And this trend is also now sweeping academia. And you see initiatives like material data informatics at University of Buffalo and elsewhere. And so I feel good that the community is realizing the importance of this. Corning particularly is doing a lot. We have what's called a data culture, very similar to what you may call a safety culture, that we have to digitize the data, we have to put it in a proper database so it can be searched and archived for future applications, and we can find nuggets in that data that otherwise would not be easily obvious to a scientist or engineer. So absolutely, and modeling also, I would say that Corning, which is one of the oldest and largest R&D company in the US, we spend a lot of effort in modeling. We have a large group called Modeling and Simulation, and we use them to cut down the cost for processing, for energy, for inventing new products, for optimizing materials. So both of these are, of course, very important, and this is where I think we need new skills, both for the incoming talent as well as to retrain the scientists and engineers that are already on the staff.
Very good.
So, you want to go?
Oh, go ahead.
So I agree with the modeling and data analytics. We do a lot of it. There's a lot of talk and a lot of information out there on our digital twins. I'm fairly close to it in the investment casting industry. We want to model stuff. We want to analyze what's going on in the factory, fill that in, build out models so that we don't have to do iterations. We don't have to make something every time we want to make a change, have to actually go through the entire process, take 4 weeks, and then do the evaluation at the end. We want to be able to model that. We want to be able to move around different features on there and determine what's going to happen. We want to know what the microstructure is going to look like. We want to know what the dimensions are going to look like, and we don't want to have to spend all that money to actually do full castings in that industry. I was really close to this in the battery industry as well. We were collecting tons of data. I think one of the directions we need to go is we have experts in data analytics, but didn't know anything about materials. And then we have materials people, but they didn't know anything about data analytics. So somehow getting someone who's an expert in data analytics and materials so they know what to look for, what's important. Many times they would come back with analysis and say, was that important? And we go, no, that there's no way that that's connected to that. It's just, being able to filter through that. I mean, we had 1,070 data points and tags coming in, and filtering through those to get down to the critical few that you Pareto that actually truly did have an impact. I mean, it took us 5 years till we got to the point where when something failed, we could go all the way back to what powder lot was actually in that, and what were the processing parameters, and it was powerful. I mean, we had a great battery at the end when we did decide to scale the plant back down due to cost efficiency, but we knew what we needed to do to make a 10-year plus battery.
Very good. How about our next question? Do global activities play a part in your business? Please respond. That seemed like our fastest 20 seconds, I think. I don't know. So we'll close voting there. I don't know how much discussion we have on the global activities. We got between 25 and 50% have their business come from overseas, or it's 50% responded on that. So there you go. I don't know.
How's your business overseas?
Our business overseas, well, I got to always think about who I'm talking about. So our business overseas with Allied, we're located in 9 different countries, and we have 12 facilities in those countries. So our business overseas does fairly well. It's still mostly focused in foundry businesses, and then we're promoting more iron and steel. But we're in South Africa as well as China and Brazil, Chile, U.S. So from a refractory standpoint, with a reduction in facilities in North America, some of our industries like refractories probably have a need to go on more of a global stage and be more competitive there.
Well, for Corning, as it's well known, more than 50% of our business comes from outside the U.S. That's where customers are, and that's where expansions are taking place. Although we have a lot of expansion going on right here in U.S., in North Carolina, in Kentucky, but in Asia, we are building plants right now. One for ceramics exclusively in Hefei, for gasoline particulate filters. We're building display glass plants in China as well, and these are co-located with customers. You can imagine it's a very large meters wide glass sheet, high quality for display industry. It doesn't make sense to make it somewhere and then ship it across the globe. So we co-locate in some cases where our customers are. So for us, a lot of the growth is coming from overseas. And so although we have centralized R&D in Corning, we have satellite R&D labs, and they're also growing in Asia, in Europe. We are also expanding in Germany. There's a ceramics plant for automotive applications that is expanding just outside of Frankfurt. So yeah, for Corning, Asia and parts of Europe are big growth opportunities.
GE as a global company, I'm not even going to try to go into all the different companies or countries that GE is involved with, but between our healthcare, aviation, power business, I mean, we're really branched out in many different areas, trying to make an impact in the world.
Yeah, we've done some leadership summits focusing on marketing. We've included some discussions on global startups with some of the small to medium-sized companies as well within the society. And I guess too, we would be looking at promoting the industry. We have done some exchanges with like the European Ceramic Society. We do a little bit of a student exchange there. So even that would be of interest to know if from a corporate side, if student exchange would be of interest or something they'd like to see actually more of. I know on the refractory side, we've got discussions with European Center for Refractory Testing. They are located in Germany, and they would be very interested in progressing with some more student exchange. But the next question, please.
You can get above 30 on this one.
Yeah. What does your team consider as world-class production yield in ceramic processing? And go.
This one's a tough one, Mike, since every business is different, but it'll be interesting to see what the results are.
Of course, if we all apply statistical analysis to our manufacturing, where do you think it'll end up being? And that's the time we have. Huh. I'm surprised.
Yeah.
I'm surprised. I didn't think it would be 90 to 95. I thought it would be a little higher.
Oh, really? Yeah. No, I mean, we threw around numbers above 85% for the battery on the beta double prime separation electrolyte. Again, I think it comes back down to industries, or what industry you're in. But it's interesting to see yields are that high. I'm impressed.
Well, that high, you say?
Yeah. I mean, with the defects in the ceramic components, and technical ceramics. Yeah.
Huh. Yeah, that's the thing. We're like a monolithic manufacturer for the most part. So, we kind of focus on what we manufacture and get out the door. I would say in the refractory industry, we shoot for a little bit higher than 95% if we can.
Yeah, I mean, to be honest with you, in some of the industries that I work in, above 40%, 45% yield on parts that after fixing them.
I think it depends on the complexity of the process and what sort of process window you have, and so a number of factors come into this. But it looks like the industry has very high expectations of what they consider good yield.
Mm-hmm. And I guess that goes back to recycle. So if you can recycle fairly much your finished product, that's a good thing. We can't do that too well sometimes.
The solution to pollution is dilution, or
yeah, exactly.
Materials utilization.
How about the next question then, please? Did we have this? We didn't have this already. So what is the top challenge associated with adoption of ceramic additive manufacturing today? Oh, this is a good one. And start.
You think we can top 30 on this one? Pull your phones out, guys. I think we're going down now.
Oh, and that'll be it for the polling. And these results are just in. All right, market poll by application. I'm going to have some explanation on some of these things because I'm ceramic additively challenged.
Yeah, I think additive manufacturing is certainly a big trend, as I've seen in the last 3 years at the Expo itself. They're just increasing emphasis on 3D manufacturing. So many vendors bringing the technology. In my opinion, it's the capabilities that are still challenged. For example, one would like to have high throughput process. One would also like to make attributes that can match what one does with traditional processing. So, for example, surface finish and some other aspects where you don't have as much flexibility. I think in order for additive manufacturing to succeed, one has to take advantage of the complexity that comes sort of free, as they say, with this technique. That has to be designed in the product. If you have a simple product, it of course doesn't make sense. So it has a very unique niche where it makes sense. And as the capability of the process improves, I think we will find a lot more applications, and we will be able to reduce cost and then sort of proliferate the technique much further. But today, it's a great technique for research, for prototyping, and very happy to see that the ceramic community is adopting it as much as it's being done for plastics and for metals.
Well, Kamel, is there much additive manufacturing done in Corning?
Yes, indeed. We have big effort in additive manufacturing in R&D today. Okay. We don't make any commercial parts, but it certainly promotes R&D activities a great deal at Corning. And we have experience with all sorts of materials, classes, I mean.
I guess I'm going to make the assumption that any ceramic additive manufacturing industry, they're probably taking a look at cold sintering as well. And it seems it's kind of new, but I don't know if that's a technique.
I think you bring up a very interesting connection, and I don't know that yet because I'm still learning about cold sintering. But certainly a combination of multiple new process innovations is perhaps what we need.
Yeah. Well, obviously, cold sintering would help a lot to reduce the amount of energy required in processing. So that's, I would think, a high level of interest in that.
Absolutely.
Yeah, and I'd second that. I mean, with Clive Randall's group at Penn State, we're trying to get them up for the ASM. They're actually got a grad student's going to be up there talking through it. I think combining that technology with additive is important, but this is hard. This is going to take a while. I mean, when it comes to the designers, I've had a lot of designers come and say, wow, this would be awesome if we could make this. But then when they really get down to how much it's going to save the company, it's not millions of dollars. So we've got to find that. For me, market pull right now is one of the biggest challenges, to find those big markets that can that have the valuation to be able to put the money in to develop the technology, equipment capability, we need open source equipment to work on. I mean, a lot of us have specific material systems that we want to work with, and then the equipment that's out there isn't always open source and available, and it's a difficulty to go back and forth with the companies providing the equipment to get them to say, okay, you can put your material through our inkjet print heads or in our system without voiding a warranty. So I think equipment capability is a big thing. And then you make something by binder jet. It's 30 to 50% porous when you make it. How do you densify that? What materials? How do you get a finer material to flow that will get you the density? And then even further, how do you start matching those properties of the parts that you actually did build? So even though complexity may be free, which I don't actually agree with, because when it comes to it, you're going to pay for it in materials process development, developing material systems, developing binders, and it costs a lot to develop those things. So I think ceramic additive manufacturing's got a bright future out of it. I think we're in a hype phase right now, but we've got to find those killer applications and start working towards those. And there's some of them. I mean, you talk to some of the additive manufacturing companies and equipment suppliers, they found some of them. I mean, at GE, we're interested in additive manufacturing. I mean, dense ceramics, dense alumina, silicon carbide, but it's still in its infancy. And everybody seems to think that they can just ask me for a silicon carbide rotor or stator, and I'm just going to go get it for them. And I'm like, it's just not there yet.
Doesn't happen.
And if it is, let me know.
Yeah. Kamel, what about with glass? Additive manufacturing, is there an application on the structural side for that?
So can you repeat?
Say structural glass side, does additive manufacturing come into play there at all?
So the beauty of this technique is that many material systems can be processed with it, including glasses and ceramics. So for us, we're still learning what it can do for glass. We have a very active program. But it's not at a stage where it can be used for large-scale manufacturing. As you know, Corning has very unique processes that we invented for optical fiber, for display glass, for Gorilla Glass, and at this stage, we are just trying to assess what potential it has. But certainly, very active enabler for many of the R&D programs.
Very good. Well, let's move to the next question, if you don't mind. What role do you foresee digital and big data playing in ceramics applications? Ooh, take 20 seconds and vote, please.
Hopefully limited to none doesn't win this one.
Yeah, not really. That comes in with the input. Just like we talked about.
Doing this, I'm noticing there's a big one missing.
Yeah.
Reliability.
And if we could, let's poll the results.
That's impressive.
What do we got? Oh, the biggest part was guidance for next generation materials. Okay. That was like 63% on that one. So and then we have increasing yield and improving efficiencies. So big data. I'm not a big data guy. I'm big on data, but I don't play with big data very much. So we haven't gotten into that yet. We still use our data mostly from quality control and product development side.
Yeah, I'm not really involved with the guidance for next generation materials, but we put it up there because we thought of it, and I think in the future it definitely it's kind of like the holy grail.
Yeah.
I want these properties, and I don't know if it's going out and getting the data from the literature and what's been done, or screening through and down screening from 5,000 different compositions down to those 50 that are most likely to give you that product you want.
Well, the big data I typically see is cost of the existing materials, so that's probably going to drive some of the new materials. I don't know.
Yeah, I think this is a great opportunity for glass and ceramics industry, because we have pretty much most of the periodic table at our disposal. So humanly, I mean, we can only design compositions with such complexity. So big data here can really guide us to finding next generation of compositions, even for the materials we know today. Can we design a better gloss? Can we design a better ceramic? So I agree with the community here that big data will help us invent new materials, compositions that we just couldn't imagine before. And we see that coming out of academia as well. Like I mentioned, University of Buffalo and other material informatics initiatives, they're finding nuggets by stringing together all the data and saying, let's do this composition. And they're not looking for marginal improvement in properties, but sort of drastic orders of magnitude improvement in properties, like all sorts of important properties for ceramics. So I'm very excited about where it can lead us.
Okay. Well, now that's another feature. We've talked, the society's been investigating big data, the use of big data and handling of big data. Now, we started some discussion with those who know more about it than I do, for sure. So, that might be part of our future programming, is to have some big data meeting, if you will. We have the next question, please. What percentage of scrap produced by your company is recycled? And go ahead and poll that. Ooh. And that is our time for the poll. Let's tally the results. Less than 25% of scrap is recycled by 53% of our respondents.
I think this probably should have been added on or repurposed, because I think that it can be a little bit confusing, because if it's recycled into the same product, it's one thing, but if it's a lot of times the scrap that was produced at GE is either repurposed or goes through another process. And I would say we try to get to 100% of repurposing what we're using.
Mm-hmm. Yeah, I agree. It may be a little bit confusing because we try to use 100% of our scrap as recycled, but we only use about maybe 5 to 10% at a time. So.
Yeah, I think there are many limitations, I'm sure, as the community feels that if you have scrap, maybe it doesn't have the right purity and the right condition to be reused. So that's why it's important to repurpose it, or your process just doesn't produce very high quality parts, or it's hard to eliminate some of the defects in these high temperature processes. So this remains a big challenge. I mean, it's certainly not up to semiconductor industry type of yields. But clearly it has a big implication for us in terms of energy and sustainability. So this, I'm sure, is a very important thing on everybody's mind here.
Yeah, and it's tough in ceramics. A lot of times we're trying to get corrosion resistance, strength, and the properties that we're trying to create. You make a component that's very difficult to break down and recycle at the end of the day and have it be energy and cost effective.
May we have our next question? Which applications for advanced ceramics have the highest growth potential? And go. Tons or pounds?
Yeah. Because there's a very different answer.
That's right. A lot of people like to do
Probably should just go medical.
That's great. And I think that's all the time we have for that one. Let's tally our results. Electroceramics. Electroceramics, wow, by far.
Wow.
All right, we got a lot of ECD guys in here. Is that what it is? Because I was going to say refractories, but I guess not.
Yeah, I'm actually surprised with this. I mean, I know electroceramics is one of the biggest markets, but medical is also one of the largest markets. And after hearing Gordon speak on Tuesday, I would have thought there would have been more. And I think maybe medical, if it wasn't medical implants and just medical in general, maybe would have been higher. But on the electroceramic side, I'm not that involved with that research right now. But anything, Kamal, that you...
Yeah, well, I think maybe it pulls so high because there's so much content of electroceramics inside the cell phones. And I think as we heard Monday or Tuesday and Wednesday, that the ceramics community is gearing up to find new opportunities in the energy storage space, right? Mm-hmm. So lithium battery materials and way to protect it. Even, yesterday speaker said ceramics make batteries look good. So there are many opportunities that I'm assuming that when people think of electroceramics, they're also thinking in terms of for the energy storage. So it's not just that the material itself has a function, but somehow it's helping making better lithium-ion batteries or other forms of energy storage.
Yeah, that's a great point because I sure forgot about that, and I was even exposed a little bit to some, some type of cell for, the wind-powered storage of that energy, and I guess that also would apply to solar as well. So, yeah, that's a good point. That's something I know that I hadn't thought about.
Yesterday, we heard from a speaker from Ford that the current lithium-ion batteries have a safety problem. They may explode, catch fire. But if you replace that liquid electrolyte, which is organic, with a ceramic electrolyte, so this is perhaps a very exciting opportunity for the whole community.
They wouldn't consider a refractory case by any chance, would they, for that?
I think you should certainly look into that space.
Can we have the next question, please? What processing steps presents the most opportunity to improve desired properties in your material? And if you would take 20 seconds to answer that. And that concludes our polling.
I think I got mine in.
All right. We have milling and sintering to be tied for our respondents. Let's take one more look, give some consideration here to improve desires in your properties. What processing step? Okay. Well, sintering would obviously include lots of energy for the most part, at least speaking from traditional ceramic side.
So I think sintering, of course, is the most fundamental process to this community. So not surprising to see it there. And in that area, I think there have been many developments, cold sintering from Penn State, from my alma mater, Lehigh University, a lot of work in understanding the microstructure that's produced by sintering. So grain boundary structure, as now explained by Professor Martin Harmer's group. So there's just a lot of work going on in that space, and that's good because this is a very important process for our industry. And I'm sure, when people mark milling as an important process, if you don't have the right milling, you wouldn't end up with nice homogeneous ceramic parts. So it's not surprising to see a tie between the two processes.
Well, that would be a question I just thought of, Kamil, was with milling, is the process itself, is there a need for improved milling processes in order to achieve, I'm guessing we're looking at nanotechnology here.
Oh, absolutely. More efficient milling that maintains the purity of the materials. Mm-hmm. So you do not contaminate your ultra-high purity materials in the process. Certainly more energy efficiency. getting the right particle size distribution and the particle size that you need. So clearly, yeah, very important.
And I guess that's another thing I never would have thought of. Well, I do from time to time, but refractories are not so concerned with. We're concerned with quality. That's of the materials or the raw materials. But you start thinking in some of the more advanced ceramic applications that obviously the milling media and the milling equipment can contribute to the bad quality, I guess.
Absolutely.
Yeah. So I hadn't thought about it. That has to be considered as well. Excellent.
Yeah, I've got a lot of experience on the milling side, and I've evaluated a lot of different technologies, and you can tremendously make a huge impact on your product by changing between ball milling, bead milling, depending on what you need. If you need high-tech ceramic and you want to minimize defects, you'll consider filtration as well on the end of the milling to eliminate large particles in there. So I think there's advances and opportunities in the milling and continuous milling area. Sintering is one on the additive side that I think is going to continue to become more and more important. And I'm combining sintering with burnout when I say that. I mean, a lot of these new ceramic lithography processes out there, they're taking 4 or 5 days to do burnout cycles and do sintering. So huge opportunities there for research and development, looking at alternative binder systems, alternative means for sintering to get that binder out of there without having to be in an air furnace for long periods of time. It's not cost effective from an energy standpoint. So again, it's another driver where you have to have a lot of value in the product you're making because it takes so long to debind the components. On the sintering side, the cold sintering is of interest, spark plasma sintering, high temperature sintering in general with all the different materials under different atmospheres. I think there's a lot of opportunities to learn, but it's expensive equipment. Yeah.
Well, and I noticed too that other processes are being considered. I mean, that was nearly as high a number of respondents on that as the milling and the sintering. So that's an interesting point. I mean, that might be something that we could come back to on questions later. Can we have the next question, please? What material areas do you foresee significant growth in the future? And we'll start with the polling. Ten seconds. And that will do. So can we see the results of that poll? Silicon carbide, silicon nitride, and alumina. Well, I don't know if we gave you too many varied selections there, but hey, I like silicon carbide, so there you go. And one of the other things with these minerals and materials are availability. So again, that's what we're finding some areas, particularly like in the silicon nitride area, availability of those silicon metals, silicon nitride, they kind of go hand in hand. So, and even now there's a bit of a talk about scarcity of aluminas. So those are always our concern on our industry side.
Yeah, on the silicon carbide side, I think it's pretty interesting. I would say 50% of the additive requests that come across my table are for different silicon carbide materials. I mean, I think for corrosion-resistant components that you can't make with injection molding or traditional processing, green machining, they're complicated enough where you need an additive process. So I see this as an area that if someone figures out how to do it and how to make parts with good mechanical properties, high toughness, there's a lot of potential for growth in silicon carbide.
Yeah, we don't have major products in these categories, although Corning makes cordierite ceramics, which is used in automotive applications, and it now represents one of the best growth opportunities in our world of ceramics to make gasoline particulate filters, which is needed to reduce pollution coming out of gasoline-powered cars, specifically in Asia and in EU. So very soon, cars will have extra ceramic component in there. That's why Corning is expanding in Europe and China. But I don't see it there, but I just wanted to mention.
Okay, very good. So can we move on to our next question, please? What safety consideration is most important to you? Please respond. Mine right now is, having lived in Alabama for 30 years, I noticed there's a couple of exits to either side of the building. I know earlier it sounded like a tornado was coming down on top of us, but that's okay. And I guess back here, I don't know if we got a railroad going or what.
Yeah.
And that's the end of that poll. Results being tabulated: chemical use at 45%, and then we have high temperatures, nanomaterials, and protective safety equipment at 15. I'm guessing maybe the PPE comes into consideration. I know in our industry, silica is definitely a major issue right now. So it's getting your employees to wear their PPE, respirators and gloves for the most part. That's going to be a challenge starting here in June of this year for most of us in the refractories industry.
Of course, chemical use obviously stands out as a very important consideration. I think the nanomaterial one is also important, and looks like at least 1/5 of the audience find that to be important. I just wanted to mention that there are no particular regulations in that space, and also the best engineering practices are not known in the nanomaterial space. At Corning, several years ago, we introduced a safety course in nanomaterials. That anybody who deals with nanomaterials has to go through that. So, simple things that you can't open a bottle containing nanomaterials in open air. The materials practically have no mass, and they represent a safety consideration because we don't know what they're going to do to us. Even materials that are innocuous in bulk state may be harmful in nano state. So this is again a very new and emerging area, and at least many of the audience here have identified that. Of course, chemical use, glass and ceramic industry use very harsh chemicals, including hydrofluoric acid, and we have to find alternatives or use proper PPE and use a lot of good practices. And high temperature too. In ceramic industry, nothing happens, below several hundred degrees C.
We love high temperatures in the refractory industry.
Yeah, I think I like to start out all of my operational meetings talking about safety and continuously bring it up so that it's a top thing on the team's mind. I don't want to get complacent about it. I mean, nanomaterials have been around for a long time now, but we got to keep reiterating how important it is to handle those materials properly and keep everybody safe.
And I guess we got one more question. Let's take a look at that. What is the largest failure mode in your ceramic processing? This should be interesting. Start. Oh, got two that knew right away what it was. And that's the time we have for that question. Our results just in. Cracks in pores and inclusions. Cracks are always an issue with refractories and probably any monolithic ceramic. And porosity also. So I'd have to agree with that.
It's interesting to see for me for cracks. Some of the processes that I've worked in, it was other things that were the number one failure mode. But cracks would be interesting to talk more about when they form. Are they actually there in the green state? We just don't see them. I mean, I think there's a big opportunity there to start to identify methods to detect cracks in the product that's coming off the line. I mean, I know at times we've made parts in the ceramics industry where we were making our ceramic electrolyte materials, and we would have what we call body cracks. We'd throw out 1,000 pieces. I mean, it was tens of thousands of dollars, but if you had a means to identify where they were, and we worked on a lot of that, but when the actual cracks occur, I think it's important to find out, and then it looks like there's a lot of opportunity there to develop processes to identify them.
If we had customers listed, I wonder how many would have changed their response.
For Corning, the kind of ceramics we make highly engineered porous honeycombs for automotive applications, emission control. And for us, pores are not a defect, it's a feature. And we like to get better at that. And that's how our products derive their filtration capabilities for emission control. But cracks, of course, when you have highly porous materials, we have to strengthen the material so it doesn't crack under any kind of stress state or in application.
Well, that's the end of all of our planned questions. I think we've got some time that we could take some additional questions from the audience. If you want to step up, looks like we got one microphone. If you want to step up to the microphone, ask a question, have a little more discussion about some of the earlier questions, feel free to go ahead and stand up there and let's hear what you got to say. You got 20 seconds.
Can I ask you a question about silicon carbide? So within the common machining, like micro machining technologies like EDM, laser, and UIG, diamond drill, which technology you think has most efficient in terms of machining time and precision for silicon carbide? And do you think is there any new technology for next generation machining process for silicon carbide micro machining?
So our question is, do we think there's new processing out there for manufacturing of silicon carbide, and is part of that also the milling question?
Machining.
Yeah.
Machining.
Like a small diameter hole drilling or milling.
I'll be honest, I'm not close enough to it to answer that question. I think you'll have to find the silicon carbide experts. I'm just dabbling in the industry, and there's a lot of interest in building it directly so they don't have to machine it. I think that might be the next step in that industry.
Yeah, I know. I don't have much either on that, other than I know that there's probably a need for processing has to be reviewed, because right now that's a really energy-intensive process just to start to get the silicon carbide form. So I'm thinking too that there's probably going to have to be some new techniques in the further processing downline in beneficiating that mineral.
Yeah, and there's some companies around here doing it. I mean, there's some companies doing it ultrasonically. I encourage you to make sure you touch base with them.
Yeah.
Ooh.
Historically, people have always wanted a ceramic with the fracture toughness of a metal. Have we kind of just accepted the limitations of ceramics mechanically, or are there new strategies that we might be able to use to improve toughness in ceramics?
I'd say that's a really good question, because in the past we have looked at elastic properties of refractory materials, and you really have to evaluate the end use of the product, because we've even found the big push is everybody says stronger is better, but in some cases that's not the case. We looked at the elastic modulus of some castables, for instance, in steel ladle casting, and because you get thermal shock developed, you have to be mindful. There's limitations as if you start to increase the elastic modulus. With a little lower elastic modulus, we tend to think that we're making the refractory a little more flexible, which might be something like Gorilla Glass. I don't know. Is there any consideration in that, Kamal?
Well, yes, Gorilla Glass is, of course, very tough. That's why it's on billions of touchscreen devices. But maybe the best answer to the question is that there's so much effort in composites, and that's partly to sort of achieve better fracture toughness that cannot be achieved with the best monolithic materials today.
Yeah, I think there's a lot of interest in it, and on G's side, it all comes down to the ceramic composites, ceramic matrix composites to get the ductile behavior. I mean, there's examples of in literature where it's been done, but there's a whole nother class of materials that doesn't exist today, and I don't know the roadmap to get there.
Good question, though. Well, we could take one more, but I guess I can see by the old clock on the floor,
Time's up.
time is up, I think. I just want to thank our panelists today, Kamal Soni and Patrick Wilson, for participating. Certainly enjoyed your responses, and very thoughtful responses at that. So, and thank you all for participating. I hope this whole interaction program was something a little unique and different, and we can continue with that in the future if you find that enjoyable. So, thanks again, and enjoy the rest of the expo.
Thank you.
Thank you.